Okay, good afternoon, everybody. So this is the last lecture. Okay, we have a lot of work today. So last time I told you input capture is used if you want to measure time. Okay, so the idea is that for input capture there is a pin. So the signal, you have to apply the signal here. The signal you want to measure, you have to apply it on the pin, this pin. Is that okay? For example, I want to measure the time from here to here. So you have to apply here on this pin. And the way it should work is, as I told you last time, so what we have here counter. This counter should count from 0 until 65,535, and then go again from 0 until 65,535, and go again from 0 to 65,530. All the time, okay, 35, not 6, 35. All the time is doing that, right? Also, every time it rolls from 1111 to 000, it should trigger overflow interrupt. So here, timer overflow interrupts. Is that okay? Now, make it very simple. Now, I want to measure the time. How can you measure the time? As I said last time, we're gonna measure the time in number of counts, okay? Not in second. And then you can convert to seconds or microsecond or whatever. Number of counts. So I want to know from here to here, how many times the timer counted, right? Because the timer is gonna count with a constant rate, like as I said before, every count should take a certain time, 1/f, okay? So if I know how many counts, it's easy to get the time. Is that okay? So the question is, how I can get the number of counts. So all what I need here to know, number of counts, okay? How I can get them? Very simple idea, okay? Or the way you have to get it, guys, for example, if I start from number 7 and I end at number 10, so it should count here 3 times, just subtract. However, this is not always the case. This is not the general case, okay? For example, I'm gonna start here from a certain number, okay? And then it's gonna go all the way to here. For example, I'm gonna start from 100, and then I'm gonna end at 7 here. Is that okay? So in this case, how I can calculate the number of counts? So the idea is that here, from here to here, the way you have to do it, from here to here should be 2 to the power 16. Okay, that's why I need to know how many overflow I have. I need to know how many overflow. So the number of counts should be how much is this part plus this part. Is that okay? Plus 2 to 16. Anyway, to make it simple, as you will see right now, in order to count the number of counts, in order to compute the number of counts, I need 3 things. Number 1, what is the beginning count? What was the count in the beginning? Beginning here means here. What was the count here? This one I'm gonna call it each one. Okay, what was the count at each one? Also, I need the count at each 2. This one. Number 3, I need to know how many overflow happened. Number of overflows. Is that okay? However, I should start to count overflow from here. So from here to here. That is why, as you will see right now, the timer interrupts are going to be disabled. I'm going to enable them here because I need to count overflows. How many timer overflows from here, starting from this point. Is that okay? Now, if I have, so I need 3 numbers. The beginning, the end, how many overflows. And using these 3 numbers, I'm going to have a formula to count how many counts you have, okay, as you will see right now. Okay, remember, we're gonna have 1 interrupt here and another interrupt here, so we're gonna have 2 interrupts. Okay, so that's why here in the interrupt subroutine, as you will see right now, I have to know. So in order to measure, I need 2 interrupts. That's it. Okay, after the 2 interrupts, I already have the numbers. I'm going to use the numbers to do the calculation and get the number of counts. Is that okay? So that's why, as you see right now, I'm going to count this interrupt number 1, interrupt number 2. Okay. So what should happen is that, look here, guys, in interrupt 1, So I'm going to have a variable. This variable should count. Is that interrupt 1 or interrupt 2? In interrupt 1, what should I do? Think about it. Number 1, I'm going to have a memory location. I'm going to call it H1. I'm going to store TC. For example, TC2, TC3 based on the channel. Okay. So remember, as I told you before, this number is going to be stored in a register called TC. So I have to take this number, store it somewhere. Otherwise, when this one comes, this one is going to overwrite it. I'm going to lose it. Okay. So the first thing I have to do in interrupt 1 is I have to store the count. This is the first count. I'm going to put it in each one. This is number 1. Make sense? Number 2, because I have to enable interrupt. Timer interrupts. Timer interrupts. Okay, because I want to count how many interrupts should happen from here to here. So, okay, makes sense. So I'm going to enable timer interrupts from here once in the first interrupt. So once I receive the first interrupt, I'm going to enable timer interrupts to count how many overflows I have. Okay, number 3. And now I'm going to ask input capture, please input capture. Now you should capture falling edge. You should capture falling edge. Initially, it should capture rising edge. So in the very beginning, in the initialization, I'm gonna ask input capture. I'm gonna program it as I explained last time to capture the rising. Okay. Once after the first interrupt, I'm gonna say no. I'm gonna change the configuration, and now you should capture falling edge. Okay. This is the 3 things I have to do in interrupt number 1. Is that okay? Now, what should I do in interrupt number 2? In interrupt number 2, first H2 should equal TC2 or TC3, whatever channel you are using. Okay. So I have to take TC, the register. I have to store it in a memory location. If you don't do that, this register is going to be overwritten. Okay. So anyway, so I'm going to take this value. I'm going to store it in H2. So now I have H1. So I have the count here and I have the count here. A number of overflows already counted by the timer interrupts. I'm gonna talk about this. Forget it for now. Okay. Say what else I should do after doing this one. What else? What you have to do is I have to disable input capture. Okay. What happens if you forget to do? Number 1, why I should disable input capture? Why? Simply because I already got H1 and H2. So now I'm gonna do the calculation. What happens if you forget? If you forget to disable input capture, what happens is that maybe more signals are gonna come in, and H1 and H2, their values are gonna change. So this is how it is. It's like you are gonna take a snapshot. You are gonna get a snapshot. Okay, that's what I want to say. Okay, just a picture. You want to get a picture. Okay, what I mean here by one picture. For example, if this signal, yeah, I don't use Snapchat, by the way, but my kids do. My kids do like it too much. So anyway, so what I'm saying is that, guys, I want to measure the signal from here to here. Is that okay? So I'm gonna, in the very beginning, I'm gonna enable input capture. Once I capture this one and I capture this one, now I'm gonna disable input capture, right? Unless I want to do another round of measurement. Anyway, so what I'm saying, the reason I want to capture input capture here, guys, because if you forget, what's going to happen once this one comes, you are going to change H1 and H2. You are going to change them before you finish the calculations. Anyway, so is that okay now? Okay, now, this is very interesting now. So I'm going to write the program in. I'm going to use 3 interrupts. I'm going to use 2 interrupts. This is for input capture. This one also input capture. Now, also for the timer overflows. In the timer overflows, guys, I'm going to write here, I'm going to increment a variable, we call it overflow, right? So I'm going to have a memory location. I'm going to call it overflow because I want to count how many overflows. Is that okay? Again, once you have H1, H2 overflow, you can do the calculation. Anyway, this is just a very high level description. I'm going to give you the details right now in this program. So here, yeah, that's exactly what I'm saying here. So in input capture, in the first interrupt, I have to take this one. Also, you have to do two more things as you will see right now. In the second interrupt, I'm going to take this one. For the timer overflow, I have to increment so overflows. Is that okay? Once you have the three values, now you have this equation here, the equation here. Okay. However, look here. I'm going to have two equations. Okay. If you see, guys, here they are exactly the same thing. The only difference is this one. I'm going to take the number of overflows I counted. This one -1 because the first overflow should not be counted. Okay, I'm going to tell you how. Okay, to understand it. So, for example, look at this case here, guys. I started from here, from H1. Okay, so I'm going to go, for example, here. I'm going to go until here. Okay, so in this case, as you see, how many counts I have. Number one, I did 2 to 16. That's why here I'm going to use this one. So here I'm going to 2 to 16 plus this part. Is that okay? So the first overflow should be counted. And this is exactly the first case. When H2 is greater than H1, when H2 is greater than H1, so the first overflow should be counted, as we see here. However, if H2 is less than H1, the first overflow should not be counted. I'm going to tell you why, as you will see right now. Look here, guys. I'm going to start from here. I'm going to start from here. I'm going to come here, and then I'm going to come here. Is that okay? So all what I have is just this part and this part, okay? So, and now also I have overflow. So this overflow should not be 2 to 16 because I didn't make a complete round. Anyway, just to make it easy, guys, all what I'm going to do now, after I calculate H1 and H2, I'm going to see which case is that H2 is greater or less. And then here, if it is greater, for every overflow should be 2 to 16. Makes sense? Overflow means I made a complete round from 0, 0, 0 until 1, 1, 1, 1. Okay, so plus the difference, which is this part. However, if it is H1 is greater, so here I'm going to decrement 1 from the overflow. Is that okay, guys? So anyway, let's see the program, how I made it. So here I made the program in assembly. Also, I made the same program in C. So let me explain the C, and then I can go quickly to the assembly one. So here, as you see, guys, as I told you, I'm going to make a variable here. I'm going to call it interrupts number, okay? Because all what I need, to do measurement, all what I need only 2 interrupts. Is that okay? For each round, you can measure more than one time, right? So every time you want to measure, I need 2 interrupts, okay? So here, so that's why I'm going to have a variable here. This variable is called interrupts number to tell me what is the number of that. Is that interrupt number 1 or interrupt number 2? Because I have to do different things. If it is 1 or 2, I'm going to do different things, okay? As you see. And you look here, guys, in the main program, for sure, I'm going to do here. Here also, I have H1, I have H2, I have overflow, as you see here, okay? Also, for sure, they have to be here. Here, I initialize them, but they have to be global because they are going to be used by the main program. Also, they are going to be used by the interrupt subroutine. Anyway, so here I just do initialization, as you see here. I'm not going to talk about the initialization. However, in the very beginning, timer interrupt should be disabled. Timer interrupt should be disabled. Why? Because I wanna count overflows from here. I wanna count overflows from here. If you don't disable it in the beginning, what's gonna happen? Because the timer is working. If you start from here and there is some time here, so the timer is gonna count. If there is any time here, the timer is gonna count overflows, which doesn't make sense. I wanna start to count overflow from at this time. At this moment. That's why in the very beginning, I'm going to disable the timer, as you see here. Look now, guys. Now, in the main program, look here. What this means. I'm going to keep looping here until interrupt number is equal to 2. What this means? It means I'm going to wait until 2 interrupts happen, and then once I have 2 interrupts, it means now H1 is ready, H2 is ready, overflow is ready. So now I'm going to go for the calculations. So here I'm going to wait until 2 interrupts happen. You understand what I'm saying? So, okay. So now once interrupt number, okay, is equal to 2, I'm going to come this way. Now I'm going to do the calculation as you see here. If H2 is greater, I'm going to do this formula. Otherwise, I'm going to do this formula here, okay? It's the same thing I explained before. Now, let's come to, okay, here in the interrupt subroutine here. As I told you before, guys, for sure, I don't need to say this one. You have to clear the flag bit. You have to clear the flag bit. I'm going to increment the interrupt number. If this is interrupt number 1, I am here. If this is interrupt number 2, I am here. In interrupt number 1, I'm going to take the time, which is the count. At what count I received the signal. I'm going to put it in each one. Makes sense. Number 2, okay, I'm going to enable the timer. I'm going to enable the timer. Is that okay? Here, I'm going to take TC. I'm going to take TC0, right? I'm going to put it in H2. And then I have to disable the channel 0. I also have to disable the timer. You know why? Okay, guys, simply because if you forget, as I mentioned, if you forget to disable the channel, right? When you do the calculation here, maybe H1 and H2 are going to change, right? Because the signal is coming. I already finished. It should not measure again. I finished the measurement. You got what I'm saying? So the way it should be done is also I have to disable the timer. Otherwise, the value of the overflow is going to change. I have a certain 2 overflow. And then when I come back and do the calculation here, it's going to become 3 or 4. So I have to freeze. H1, H2, and overflow. You got what I'm saying? Until because I already finished the measurement. Okay. So as you see here, guys, in the second interrupt, I'm going to disable. Interrupt input capture. Also, I'm going to disable the timer here. Inside the timer overflow here, I'm gonna every interrupt, I'm gonna say overflow should equal overflow plus 1. Is that okay? Because I want to count how many overflows. Any questions? I'm going to tell you something because you may need something like that in your capstone. So you may have this problem somewhere. It's a very tricky problem. Listen to me, please. This may save much time for you later. Okay? Very tricky problem. Look, why here after the first interrupt here? Okay, I should enable the timer because as I explained at this point, I should start counting overflow interrupts. Is that okay? So here I'm going to enable so that every overflow that's going to happen at this moment, starting from this moment, every overflow happen is going to be counted. Make sense? So what mistake you made? Okay, I'm going to tell what mistake. Why I clear the flag bit of the timer? What happens if I forget this one? I'm going to tell you what happens, okay? What happened is, because the TA made this mistake, or even myself, I made this mistake in the beginning. What happened is that I was expecting to get 2 overflow. I found that I get 3. I was expecting to get 3 overflow. I found that I'm going to measure 4. I was expecting to get 5. I'm going to get 6. So I noticed if you don't write this one, always I'm going to get 1 overflow more than what I'm expecting. Why? I should start counting overflow from here because I enable it here. Okay, I'm going to tell you why. Because before you enable the timer, every time there is an overflow, the timer is going to request interrupt. So in the flag bit, the timer is going to put 1. But we are not going to respond. We're not going to respond to the timer. Why? Because interrupts are disabled. You got the point? So what happened, once I enable the timer, there is right away, there is interrupt from the timer overflow because this is from the history. You didn't clear the history. Again, this is a very tricky point, guys, okay? So what I have to do is that I want to start counting from here. So I'm going to say, I'm going to enable interrupts from here. Also, I have to clear the history. What do you mean by clear the history? I mean, the flag bit, I have to put 0 in the flag bit. This is okay. Again, we did it sometimes. This doesn't make a problem sometimes, okay? For example, in the test or anything in the project or anything you did, if you don't count the number of events, this is not going to make a problem. Okay, what happens is that once you enable RTI, you are going to have interrupt right away. Okay, it's not going to make a problem. You are going to start the buzzer quickly, just right away. You got what I'm saying? That's what I want to say. However, if you use interrupts to count, if you want to count something, this is going to create a problem. Okay, guys. So what, again, I'm going to say for last time. Okay, so what I'm saying is that we have the flag bit. I want to start counting from this time, from this moment. I want to start counting from this moment. The problem is that the flag bit is already one from the history, because I told you before, the device can request interrupt. So it's gonna put one here in the flag bit, okay? But because it is disabled, I'm not gonna serve this interrupt, but still there is one right there, okay? So what happens, I wanna start counting overflows from here. So every overflow come, I wanna count it, right? However, already there is one, once I enable timer, right away, timer is gonna trigger interrupt right away, okay? Because there is already one old one here. So that's why to solve this problem, very simple, I cleared the flag bit here. Anyway, I don't want to spend more time in this. Hopefully you understand it, because this is somehow tricky. And this is gonna mainly create a problem if you wanna count a certain, you are gonna count from a certain point, okay? Number of interrupts. Any question here, guys? So let me go through it quickly. So what I'm gonna do here, guys, I wanna measure a signal. This signal is connected to TC0 or channel 0, sorry, channel 0 or T0 or port T pin 0, PT0, okay, or channel 0. So as you see here in the main program, I'm gonna wait until 2 interrupts happen, because that means I already finished the measurement. Now I'm gonna do the calculations. So I need to wait for 2 interrupts, as you see here. Once I already had 2 interrupts, so now I'm gonna just use the numbers I get from the measurement, okay, just to do the calculation as you see here, okay. Here in the first interrupt, as I told you, if this is interrupt number 1, I'm gonna take this value, I'm gonna store it in H1, right? Then I'm gonna clear the flag bit for the timer. Then I'm gonna enable the timer so that I start counting. At this moment, I'm gonna start counting overflows. So that's why if you see here, every time there is overflow, this variable is gonna be incremented. Is that okay? If in case of interrupt 2, so TC0, I'm gonna put it in H2 here, okay? So what I wanna say here is that, I want to tell you something also. I know it's somehow tricky to students. Listen to me. So now, it happened to me before, but I'm going to tell you that what is the issue here. I'm going to tell you what's the issue. Now, to configure the pin, as I told you before, I can capture only falling. I can capture only rising. I can capture both falling and capture both of them. I can capture both. Is that okay? So in this program, it seems to me I already selected this one. I want to capture both, right? Keep in mind, this should be okay if the signal is something like that. If this is the signal, okay. So I'm gonna have one here and one here. Should be okay. Should be okay. Is that okay? However, you are gonna have a problem if your signal something periodic, something like that. If your signal is this way, you may have a problem. You know why? I'm going to tell you why. I want to measure the time from here to here, okay? So I'm going to capture the first rising and falling. Is that okay? Rising or falling, okay? So here, it depends on where do you start. If I start measurement from here, so I'm gonna capture these 2. So I'm gonna measure correctly. However, if I start measurement from here, sorry, not from here. Yeah, for example, if I start from here, for example, so what I'm gonna do, I'm gonna measure the time from here to here. So sometimes, if you wanna capture both rising and falling, sometimes it makes problem. Okay, so I wanna measure the time from here to here. Okay, but however, if I start measurement from here, and you may not have a control in this. Again, it depends on how the signal looks like. Okay, so if I start from here, actually, I'm gonna measure this part from here to here. Okay, so if you have a concern that this may happen, so there is a smarter idea. And instead of capturing both, okay, you know how I'm gonna do it? Very simple. I'm gonna tell you how. So the way I'm gonna do in the initialization, I'm gonna be very specific. You have to capture rising, only rising, okay? So that if I start from here, it's not gonna capture this one. I'm gonna wait until the first rising. Is that okay? So in the very beginning, I'm gonna be very specific. Okay, so, and then here, after the first interrupt here, I'm gonna say, after the first interrupt, now I'm gonna change the configuration. I'm gonna say capture falling. Any question? You got what I'm saying? What I'm saying, guys, is, okay, I'm gonna say it again. What I'm saying is that, how can you configure the pin? You can configure the pin to capture both rising and falling. And this may be okay if your signal looks like something like that. This is okay, because I'm gonna have rising and falling. So one here and one here, that's okay. However, it may not be okay in other cases. If you have a signal like this, for example, here, and I wanna measure the time from here to here, okay, it's gonna be, there is a risk. What is the risk? If I start measurement, for example, from here, so the first rising and falling, I'm gonna measure this one, which is okay. However, when you start the measurement, if the signal was here, that means you are gonna measure the first rising and falling. Because rising or falling, it's or. So you got what I'm saying? This one or this one. So interrupt here, okay? So I'm gonna measure this one instead of this one, okay? So you can be smart, or in this case, you can solve this problem. You can make it more accurate, in my opinion. So the way you can do it very easy, here in the initialization, you can say capture rising, only rising. Here I'm after the first interrupt, I'm gonna say capture falling, only falling. Is that clear? And I think that's what I did in C, and sorry, in the assembly. I'm not sure if this is what I did in assembly or not. But anyway, this is something you can do anyway. So here, I'm not gonna talk about the assembly because it's exactly same thing like C. So yeah, same thing, exactly same thing. But as you see here, guys, I'm gonna wait until I receive two interrupts. Once I receive I'm gonna do the calculation here, and here in the interrupt here, I just in the timer interrupt, I just increment overflow. So I'm not gonna spend time on this one. And also here in this one, look here, guys. As you see here, number one, I'm going to increment the number of interrupts, as you see here. And if the number of interrupts are one, if they are two, I'm going to come here. This is interrupt number two. Interrupt number one, I'm going to here. This interrupt one, this interrupt two. So interrupt one, I'm going to store TC0 in H1. Okay, then I'm going to enable the timer to start the overflows. Also, I'm gonna clear the flag bit as I told you. Okay. Any questions? Yeah, sure. Oh, that's another issue. So my understanding, you want to say if the signal has bouncing, is that okay? Here, I'm assuming there is no bouncing. You got what I'm saying? Yes, for sure. If there is some bouncing, so for example, after the first, yeah, if the signal something, okay. So I'm saying I'm expecting signal this way, but maybe I'm gonna have signal like this way. Okay, this way. Yes, for sure. So in the first interrupt, I will be here. I can wait some time until it is here, for example, and then you start from here. But still, you are gonna have issue also because yeah. So you can wait. You can after some time you start counting here for the timer. Yes, you can do this way. But anyway, but the issue here is that I don't see this is gonna be like a practical problem because bouncing comes from mechanical. You got what I'm saying? Again, it depends on the application. But if you press a button, I don't think I'm gonna need to measure this one. But anyway, yes, you can consider for sure something here. After the first interrupt, I can wait some time, something like that. Yes. Anyway, so I think, okay, let me tell you what I did here first. Look here, guys. Here, I have a signal like this one. Okay, I have a signal like this one. I want to measure the period. That's why here it doesn't matter if you start from rising or falling. So here in this case, guys, so here I should not worry about I'm going to start from rising or falling. Why? Because if I start from here, I'm going to measure. Yeah, I think this program I capture only because it's a signal looks like this way. So I'm going to capture only rising. Okay, so I'm going to start from here, measure until here, only rising in this program. I think, yeah, I modified the program here. So here's the configuration. I'm going to capture only rising, or you can capture only falling, because this is a period. You can capture only falling. This is also a period. However, I was talking about a different case. I was talking about this case here. Okay, if I want to capture a pulse like this one. Okay, so that's why I told you here, guys. Here, as you will see right now, in the configuration, the very beginning, I'm gonna capture rising, and then after the first interrupt, I'm gonna change the configuration to capture falling. Yeah, that's what I did. Look here, guys. So what I did here, comparing. So I want to show you what is the difference. I want to show you what is the difference between if my signal is this way and I want to measure the time from here to here, or my signal is this way and I want to measure the time from here to here. I'm going to use exactly same program. The only difference is here in the configuration here, I'm going to say I want to capture only rising or only falling. Okay. However, here in the very beginning, I'm going to say I want to capture rising. Then after the first interrupt, I'm going to say I want to capture falling. Okay, that's what I did. So if you see here, guys, I added this line here. Now, after the first interrupt, I'm going to say now this is the time to capture falling. Is that okay? Any questions? Okay. So the next program I want to teach you guys here is output compare. I told you we are gonna use output compare. We are gonna use output compare to generate signal. If you want to generate a signal this way, okay. And I told you the way you are gonna do it is TC should equal TC in T. TC in T is the value of the counter plus certain value. Okay. So after a certain value, the pin has to go to down, or I'm gonna toggle the pin. You also trigger interrupt. So here in this program, look here, guys. I wanna generate a signal like this one, 300 microsecond and 700 microsecond. Is that okay? The first thing you have to do is you have to convert the time to number of counts. Okay. The way I did it, guys, here based on the configuration. So here I decided to select the prescale. The prescale is 8, whatever you want to select. When I selected the prescale 8, I found that the time for each count is 1/3 microsecond. Is that okay? That means here for 300 microsecond, I'm going to divide 300 microsecond by the time of one count. So that means it should be 900 counts. So from here to here should be that the counter should count 900. Here 700 microsecond should count 2100. Is that okay? Look how I'm going to do it. That way very easy. So in this, I'm going to have one interrupt here. We're going to have one interrupt here and one interrupt here. In this interrupt, I'm going to say, look here, I'm going to say TC, whatever the channel you are using, TC0, TC1, whatever the channel. So I'm going to say TC should equal TC in T, which is the current count plus 900. So the toggle is going to be after 900. Is that okay? But if I am here, I'm going to say TC should equal TC in T plus 2100. Is that okay? So because this one, the toggle should be after 2100. Is that okay? So the question is, how can I know if I am here or I am here? How I can know? Simply, similar to what we did in several parts in this course, you are going to use a variable. So this variable is going to have two values, right? High and low, right? So one value for high, and I'm going to use this one. The other one, I'm going to use this one. So I'm going to choose a program here. Yeah. So as you see here, guys, I'm going to use a variable. This variable, I'm going to call it high or low, as you see here. Okay. So as you see, this is for sure, this is configuration. That's a very simple configuration. Let's see here in the interrupt subroutine. I'm going to check, is this high or low? Two cases here. Okay. One time I'm here, one time I'm here. Is that okay? So if it is 0, if right now I am 0, okay. So here I'm going to say TC5 should equal TCNT plus high count. High count is, which is 900. So I'm going to say next toggle, next interrupt is after 900. Okay. However, if it, and now make it 1. Next interrupt, I will be here. Very interesting. Okay. I'm going to make it 0. So the way it should work, you guys, 1 interrupt here, second interrupt here. 1 interrupt here, 1 interrupt here, 1 interrupt here, 1 interrupt here. So in 1 interrupt, I'm going to say the toggle after 900. In the other interrupt, I'm going to say the toggle after 2100. Is that okay? Also, there is a risk here. There is a risk. If I select the action to be toggle, okay, and you start from 0, yes, it's okay. I'm going to start from 0. I'm going to generate a signal this way, which is you are okay. However, if for some reason, if you start from 1, you are gonna have a signal this way, because you are gonna start from 1 every time you are gonna toggle in the first time. I'm gonna use 900 and then 2100. Is that, you understand what I'm saying? Because 1 interrupt here, the other interrupt is here. So how can you solve this problem? I'm gonna tell you how. You can simply, similar to what I explained to you before, instead of using action toggle, because I told you the action, it can be toggle. It can be high, the pin is high, or the pin is low. You understand what I'm saying? So here I'm going to say, because this is for high, this value for high. So I'm going to add a line here. I'm going to change the configuration. I'm going to say, okay, now the action is low. That means after this count, after this amount of count, which is 900, the pin is low and it's going to trigger interrupt as well. You get what I'm saying? Also, I can add a line here. I'm going to say, okay, now this is 2100. Okay. Yeah, sorry, 2100. Okay, 2100. That means I'm going to say next interrupt is after 2100 counts. And now I'm going to say after the action you have to take. The action you have to take after 2100 counts, the pin should go high. Is that okay? To be like very specific. Anyway, this you can do this way, or you can do toggle, whatever you want. So this is just a very simple. I don't want to spend more time on this one. So now, listen to me. As I told you guys before, output compare. This is the last program I'm going to teach here. So output compare, as I told you before. Input capture is used if you want to measure time. Okay, for sure. However, also input capture it can be used like IRQ. That's true. Output compare is used if you want to generate signal. Also, output compare is used like RTI. Is that okay? So now you can have 8 IRQs in this chapter, 8 RTIs. Why? How can I make the same program we have right now? How I can make it like RTI? I'm going to tell you how. Look, guys, what I'm going to do. Okay, I don't need high or low. I don't need this one. Okay, I don't need this one. I don't need this one. I don't need this one. Okay, all what I'm going to say, look here, guys, all what I'm going to say, for example, here, I'm going to say TC5 equal TCNT, for example, plus 900. What it means? This is RTI. If I do this way, this is RTI. Why it is RTI? Because for sure, I don't want to make action on the pin. That's why one of the configuration we have for the pin, you can select no action. For the pin, we have four configuration. Okay. Number 1, do you want to toggle? You want the pin to be high? You want the pin to be low, or you want no action? Is that okay? I can select the pin no action. Okay. However, when I say TC5 equal TCNT plus 900, what it means? Means next interrupt is after 900 interrupts. Okay, so this is TCNT. I'm gonna put TC difference 900. Interrupt 900. Interrupt 900. Interrupt, and so on. You got what I'm saying? So you can make periodic interrupts, and this is RTI. Okay, and this one much more beautiful than RTI, in my opinion. You know why? In RTI, I'm not going to use beautiful. I'm going to say like it's like you can you can program the time like very fine-grained, and easily to program the time. In case of RTI, we just had a table. Right now, if I make it 901, that means you are going to have interrupt every 301 microsecond. Sorry, because every one you are going to add is going to be, you are going to add 1/3 microsecond. Okay, so you can put whatever you want, number you want to put here. Very easy, much easier than RTI. Is that okay, guys? And this is a program I think I have here somewhere. Yeah, this one. So if you look at this program, guys, this is exactly similar to the program I have taught right now. The only difference you see here, I just select here the action, no action on the pin. So no action will be taken on the pin, okay? Also, you see here in the interrupt subroutine, for sure, you have to clear the flag bit, for sure. Okay, and every interrupt, I'm gonna say TC5 should equal TCNT, right? Plus interrupt period, which is a variable. So this is a variable. This variable, I put it here, 3000. So 3000 with the configuration I made for the timer. So the timer should trigger in the timer. Every count should 1/3 microsecond. Again, this is how I told you you can control this one, right? Because this one should be 1/f, and if you can control f, as I told you, it should be 24 megahertz divided by prescale. In this case, I selected prescale to be 8. Is that okay? You can change it. Anyway, so when you select 8, now every count should be 1/3 microsecond. That means if you want to trigger interrupt every 1 millisecond, you can just use 3000 here. Okay, 3000 is going to be 1 millisecond. But in every interrupt, I have to say that I have to say TC5 equal TCNT plus certain value. That okay? Very interesting, very easy, right? And is even you can, when I say like you what we did in RTI, we had interrupts every fixed time, right? But you can change it, but maybe hard to change. But here you can easily to change. For example, I can say next interrupt after 1 second, right? Now you think the system is doing very well. I don't need to check more often. So I'm going to say, no, make it every 2 milliseconds, okay? Just because I don't need, for example, I'm monitoring water, monitoring tank, whatever. So the level of the water is too low, so there is no risk. You got what I'm saying? So I can easily increase the time, decrease the time, just by playing in this number you are using here. Anyway, any question, guys? Okay. So now, I think I taught the main part here in the timer. You still have several programs. You can look at these programs. They are not hard. One of the programs is the buzzer, how I can use output compare to trigger a buzzer. We did something like that in the test 2 using RTI. So for the final exam, what do you need here? I need here only 2 programs, okay? Only 2 programs. I'm not gonna ask you to measure time, okay? I'm not gonna ask you to use output compare to generate signal, okay? So all what I need to you guys, this one, how can you use input capture like IRQ, use this program here, okay? So this is the first one I need you to know in C and assembly, right? That's very easy, right? So just okay. So what we do here, just the initialization. After the initialization, you are gonna have here, you are gonna have interrupts. That's it. So you should learn the initial. However, I do this one, I think, for a channel 0. So I do this one for a channel 0. You should know how can you do it for the other channels. It's easy. All what you have to do here, guys, for example, for this register, here I say bit set 1. Why? Because this is channel 0, it should be 1. If it is channel 2, so it has to be number 2 because this is channel 2. You got what I'm saying? So anyway, so you have to look at the registers I explained before. But anyway, all what I need from you for in this part, just how can we use input capture like IRQ in C and assembly, which is exactly this program, and I think the next one. Okay. Also, how can you use output compare as RTI, which is this program I took. So I'm not going to ask you to measure time or to generate a signal. Is that okay? Only 2 programs here. Okay. But for example, here I explain this one for one channel. I think I explained this one here. This one for a channel 5. So you should know how to do it for the other channels. It's exactly the same thing. The only difference, you have to change the number seen in the register. So if you go to the, when I explain to registers, you will find everything easy. So here, look here, guys. Yeah, for example, here, in case of TIOS, if you do channel, for example, if I want to channel 0, so I'm gonna put here 1, right? If in the exam, if I tell you channel 4, so the 1 should be here. That's it. Okay, so it's exactly the same thing, but you just change the configuration. Very simple. Okay. Anyway, that's all what I need from this chapter. Okay, only these 2 programs. Again, how can you use input capture as RTI, C and assembly? How can you use output compare like RTI? Okay. Now, I want to move to pulse width modulation. I want to give you, is this not in the final exam, as I have just mentioned? However, I think I want you to learn at least it's very easy, by the way. Okay, so quickly, let me tell you what is pulse width modulation. What is this? Okay, very simple. This is a microcontroller, guys. We have a circuit here. This circuit, we call it pulse width modulation. Is that okay? Number 1, don't be confused. This one has nothing to do with the timer system, okay? Because they are together in the same chapter, and I name the chapter timer system. Maybe you are going to be confused and think it's related. No, this one has nothing to do with timer system. This is completely a different system. This is number 1. Number 2, this one has no interrupts. No interrupts here. Also, students are confused because I have been teaching interrupts for a while. So students think this one has interrupts. No interrupts here. Okay, this is number 2. Number 3, so what is pulse width modulation? I'm going to tell you what's pulse width modulation. Pulse width modulation, guys, we have 8 channels. Like timer, yes, 8 channels. So this is the only similarity. Everything else is different. So here, so pulse width modulation, guys, we have 8 channel. Every channel has no interrupts, but every channel has a pin on port P. So this one, port P7, P6, and PB0, and so on. So we have port P. Okay. Remember, we used to port P before. We used it, right? We used it for RGB, right? We used it for 7 segment, but we used it like a general pin, like general purpose pin, right? 0 or 1. We didn't use it as a pulse width modulation. That's true, right? Same thing for the timer. When you used to, when you used the PT5 in chapter 3, I used it like a pin, not a timer. Okay, anyway. So that's true. If you don't want to use the pulse width modulation, you can use these pins as a general pins. Okay, so, but don't think that when we used it in RGB, it was pulse width. No, it wasn't. Okay, so anyway, so as I'm telling you guys here, we have 8 pins. So now let's return to my point. So what is pulse width modulation? I'm going to tell you what is this. Very, very simple, very easy. Look here. So this is the CPU. The CPU is going to do configuration here. It's going to configure some registers, write some values to registers. Okay, that's it. Once you do the configuration, I don't need the CPU anymore. Okay, so here you can generate a square wave, but the circuit by itself can generate a square wave without involving the CPU at all, unless the CPU wanna disable the signal, stop the signal, unless the CPU wanna change the frequency, right? If you don't do, if you just wanna generate a signal and leave it, okay, so all what you have to do, just to do the configuration, and that's it. No interrupts, nothing from the CPU. The signal is going to continue forever. This is for sure very interesting, because that means pulse width modulation can be used to generate a signal, a square wave signal, without taking any time from the CPU after the initialization. No time from the CPU. Very interesting, right? There is another major advantage here as well. What is that? It is, you can easily, if you generate a signal, for example, something like that, you can change the duty cycle. So I can I can do something like that, or I can do something like that. It's the same signal. So it's easy to play in the duty cycle, very easy. You'll see right now. How? just a number. You write a number in a register. That's it. Very trivial, as you will see right now. So okay, so you are telling us pulse width modulation using, but I can easily change the duty cycle. Is that right? So, and you tell us this is something, yeah, sometimes you need to do something like that. And I do it with like very easily, okay? So number one, why I'm gonna need pulse width modulation? Number one, I can do something like what you see here, guys. In many loops, like for example, a bulb, a light bulb, or if you have a fan like this one here, many loops, you can, or you have a motor, I can control the speed of motor by controlling by the voltage. As I increase the voltage, so for example, this is the voltage, this is the speed of the motor. It can be something like that. Is that okay? So how I increase the voltage? You can easily increase the voltage by increasing the duty cycle. So if you see here what I'm doing here, guys. So here I have a very small voltage. So the motor is gonna rotate like it's gonna be very slow. And then now, as you see here, I'm increasing easy. I increase the duty cycle. As I increase the duty cycle, I actually increase the voltage, the average voltage. That's why the motor can rotate, can spin faster. Okay, so this is number one. So what I'm saying, guys, is sometimes we need something like that. I need to change the duty cycle, because by changing the duty cycle, I'm going to change the voltage. By changing the voltage, I can change the speed, or and so on. So how I can do that? Because this is the main advantage of the pulse width modulation. You can easily change the duty cycle. Is that okay? The other thing is, and maybe some of you already have done this, and I'm sure many of you are going to need it in the capstone, stepper motor. In a stepper motor, all what you need to know, you need to generate some signal with a certain, you apply this signal on, you need to generate specific signal, apply it on the motor. Okay, so I'm not sure if maybe some of you are not aware what is a stepper motor. In stepper motor, it doesn't spin continuously. It's like step by step, take step by step this way. Okay, you can use it to, if you, for example, if you want to open a gate or something like that. Anyway, so here you can use pulse width modulation to like to run a stepper motor. Okay, but here anyway, so now I'm gonna, any questions? So let me summarize what I said. What I said, no interrupts here, guys. Pulse width modulation, you have 80 channel. Every channel can generate a square wave. Yes. Okay. The main advantage here, once is a CPU, once you initialize the register, once you write some values to the register, I don't need any time anymore from the CPU. In output compare, there was interrupts, right? Here, no interrupts. So in output compare, I need some time from the CPU. Here, I don't need any time. Okay, that's number one. Second, I can easily change the duty cycle, easily, as you will see right now. Any questions? Okay, now you are seeing easily. So show us how it is easy. I'm going to tell you how. Just some numbers, you have to put some numbers in registers. That's it, as you will see right now. Look at the idea, guys. How I want to generate a signal this way. How I can do it? So I want to generate a signal this way. How can I do it? I'm going to tell you how. Okay. Number one, I have a clock. I'm going to tell you how I can get this clock, but I have a clock. I'm going to tell you how, but how we are going to generate it. Okay. But we have a clock. And then every channel has two registers. One register is called the period, pulse width modulation period. So we have 8 of them. So we have period 0, period 1, period 2, until period 7. So every channel has 2 registers, right? One is called the period, pulse width modulation period. The other one is called pulse width modulation duty, right? How it works is, if I want to generate a signal like this one, very simple. All what you have to do, you have to put a number here, and you have to put another number here. For example, if I say here, just an example, 100, if I put here 50, what it means? It means from here to here, it should be 50 cycles from here. So 50 here means 50 clock, 50 cycles. You got what I'm saying? When I say from here to here, it is 100. That means it's 100 from the clock. Easy. Very easy. You got what I'm saying? So the period is going to be 100. So from to here. So when this, if this one 100, that means from here to here, we're going to generate 100 cycle from here to here. Is that okay? So that's why it's very easy. So for example, I can change it, I can make this one 200, I can make it 150, so I can change the frequency easily. Is that okay? And this one, for example, if I say, guys, this one is 100, so 100 cycle from this one. And this one is 10, only 10. So I'm going to generate a signal something like that. The duty cycle is 10%. If I make this one 50, so 50 out of 100, 50 out of 100, that means it's going to be 50% duty cycle. If I make this one 90, so it's going to be signal like this one. Very beautiful. Why it is very beautiful? Because as I told you, I can change the duty cycle easily. Nothing easier than that. Just you change this register. For example, look here, guys. For example, I'm going to make this one, for example, 100. I'm going to put here 10. So now the duty cycle is 10%. Now I want to make the duty cycle 20%. Very trivial. You have a register. Just write 20 in this register. Now it's 20%. Now I want to make the duty cycle 30%, as I did here. As I did here exactly. Look here. I'm increasing as I move this way, I'm increasing the duty cycle. Very trivial. All what I have, just one register. I put here 30, 40. For sure, this one should not be more than 100 for sure, because this is a total time from here to here, 100. Any question? Okay. So if this frequency is F, what should be the frequency I'm generating? It should be F divided by pulse width period, right? Divided by this value. Make sense? Yes, because every 100 here is going to be one cycle here. That's why it's like division. You agree on that or not? So if the frequency here is F, okay, and I say here 100, what it means? It means the frequency here should be 100 over 1. F should be divided by 100. Make sense? Because every 100 here is going to be only one cycle here. Any questions? Okay, so now I taught two registers. I already taught two registers. One is called pulse width duty, and we have 8 of them. Duty 0, duty 1 for every channel. One for every channel. We have one period. This is for the whole period. We have 8 of them. Is that okay? Is that all the registers you have? No, we have other registers. I'm going to explain them right now. Again, after we finish this part, I told you it's going to be too easy, because all what you have to do, I'm going to show quickly. Maybe I want to show one program just to understand how it is easy. This is a program. You know all what I have to do? Just write numbers. You write number to register. That's it. Once you write number to register, it's going to work. But I'm going to explain what are these registers. Okay. But anyway, I already explained two registers. I'm going to explain more. Okay. For example, here. Okay. For example, here in the very beginning. Yeah. So in the very beginning here, look here, guys. I told you we have clock, right? We have clock. And everything you write here is going to be relative to this clock. If I say 100, that means 100 cycle from this clock. Okay. So the question, how can we get this clock? How can calculate it? Is that the main clock? 20. Remember, 24 megahertz. This is the main, or the system. We call it the system clock. Okay. Any clock should be derived from this one. Yes, it is derived from this one, right? So let's see how we did it. Okay. So now here, guys, for every channel we have two clocks. One is called clock A. The other one is called the clock B. A and B. Okay. I'm sorry. So we have here scale to A and A for 3 channels. So we have here this is channel 0, 1, 4, 5. Okay. Every channel you can select. For this channel, you wanna get clock A or scale to A. For 2, 3, 6, 7. For each channel you can select. You wanna get this one. You wanna use this one with this channel or this one. You got what I'm saying? So what I'm saying, every channel has 2 sources, and you can select. You need this one or this one. Is that okay? So how can you get these 2 sources? You will see right now. Look here, guys. We have here the system clock, which is 24 megahertz. Then I'm gonna divide it by prescale. So divide, I'm gonna divide it by prescale. This prescale should be in a register, these values here. Then I'm gonna divide it by another register. We call it pulse width modulation scale A. Then I'm gonna, okay, so if you divide it by prescale here, you get it. So this is clock A. However, if you divide it more by this value, by this register, and then you divide by 2, I'm gonna get this one. Okay, so 24 megahertz is going to be divided by prescale. For sure, this prescale is a register. This is a value you can select. You can make it 1, 2, 4, whatever you want. Okay, and then this one I'm going to call it A. Then I'm going to divide it again by a byte, by a register byte. Okay, which can take a value from 1 to 256 to divide it more, and then divide it by 2, and then you have a scaled A. Is that okay? And then you can select whatever you want. This channel should come from here or come from here. Okay. We have same thing for B, but B, clock B or scaled B are going to be used for 2, 3, 6, 5, and it's the same thing. But here we are going to use a different register for prescale. We are going to use a different register for the clock divider. So simple, just in one sentence. The clock I'm going to use in the pulse width modulation is derived from the system clock, which is 24 megahertz. And to calculate it, I have 2 registers, as you see here. One is called prescale, okay? The other one is this register. Is that okay? So, and okay, so where are these 2? For example, where is the prescale? Yeah, these 2 prescales are in a register. Yeah, this register here, this one is called pulse width BWMPR clock. Okay, so as you see here, guys, we have 3 bits for clock A. We have three bits for clock B. Okay, so you can select whatever you want. You want to divide by 2, divide by 1, divide by 4, and so on. So these are here in this register. Okay, very easy. I'm talking about this part. Okay, these 2, this is just the name of the register. This is the initialization you have to do. Okay, anyway, so now let's after I did the math, after I did the calculation. So what is the if I use, I'm going to tell you why this part is important. Listen to me. So what is the clock here? If I okay, look here, guys. So what is the clock here? What is the value of the clock? Yeah, it should be 24 megahertz divided by prescale. Is that okay? That's okay. Okay. What should be here? It should be 24 megahertz divided by prescale times this value, pulse width modulation scale A, times 2, because I'm going to divide by 2 as well. Is that okay? This is the clock frequency. After all of that, this is the clock frequency, which I told you here, F, the clock frequency. Now, I want to calculate this frequency, the output frequency, the pulse width modulation frequency. I told you the output frequency, the pulse width modulation frequency is actually F divided by this register. Is that okay? So if you do the math, this is the final conclusion. The final conclusion is, and this is an important thing, listen to me. Now, if I can use clock A, I told you for every channel you can select. For every channel you can select. Do you want to use clock A or scaled A? Okay. So I should select based on what? I'm going to tell you based on what. So here, if I use A, so this is the pulse width modulation frequency. It should be, this is F, I told you about, this is F. Then I'm going to divide it by the period, right? Here in case of scaled A, this is F. Then I'm going to divide it by the period. Is that okay? So if you do the math, what is the minimum and maximum frequency I can generate? If I use, this is a main point. So I told you, for every channel, you need to select A or scaled A, right? I should select based on what? Based on how much frequency you want to generate. Because every clock is going to give you a different range based on the value here. For example, if here I want to get the maximum, so the maximum I'm going to put here 1 and I'm going to put here 1, right? So the maximum should be 24. That's what I did here. So if 24, is that okay? However, so this is the maximum frequency you can get if you select clock A. That's okay. If you select scale to clock A, now what is the minimum? The minimum when this one maximum, which is 128, and this one maximum, which is 256. So the minimum should be 732. Conclusion. Same thing, I'm going to repeat the same thing here. I'm going to put here the minimum values and maximum value. I will find, this is the conclusion. The conclusion is, if you clock A, your frequency, the frequency you want to generate must be in this range from 732 to 24. Or in this, otherwise, if you want to go scale to clock A, this one is going to go much lower, which makes more sense. You know why here I want much lower than this one? Because I'm going to here divide by 2 more registers, as you see here. I'm going to divide by the period here, I divide by the period here, I'm going to divide by more things. So that's why I can go up to 2 hertz. You understand what I'm saying? So you have to select A or scale to A based on the frequency you want to generate. This scale to A can generate a frequency in this range. Scale to A can generate a frequency in this range. Is that okay, guys? So now, everything left is just very trivial, very easy. So now I told you, you have to select every channel. You can select A or scale to A, B or scale to B. How I can do that? Very simple. Register. We have 1 bit for every channel. So for example, here, this is for channel 0, channel 1, channel 2, and so on. Very simple. So here if I put 0, so that means I want to use a clock B or scale to B. One. So here 0 for B or A, 1 for scale to B or scale to A. That's it. Very simple. Again, every channel has 2 sources of frequencies, right? You can select every. That's why in this register we have 1 bit for every channel to select. You need this one or this one, okay? And you have to select based on what? Based on what frequency you want to generate, because everyone has a range. As you see. Any questions? Okay. This is not in the final exam, but I want to teach it because you may need it. You learn it, okay? But it's very trivial, okay? Because you just are gonna write some values to registers, okay? Number 2, okay. Now, once I write some numbers to register, I'm gonna generate a signal. So this signal will be out of control. I cannot control this signal anymore. No, you can, right? For example, what do you mean by control? Can I stop the signal? Can I turn it off? Yes, you can. How? Very easy. We have a register here. We call it PWME, enable register, as you see here. Every bit can control 1 channel, right? So if you put here 0, means it's disabled. So if I put 0 here, means no signal. You cannot see the signal. You turn it off. Turn the signal off. If you put here 1, you turn the signal on. That's it. Yeah. Okay. No interrupts here. Don't think about interrupts. It's much easier than interrupts. No interrupts here. Just 1 bit to turn on and off the signal. Is that okay? This is also this one. What else do you have? I have a very easy one. We call it polarity. Polarity. So polarity means you want to generate a signal this way or this way. That's what anyway, I didn't use it. I don't know how this can be useful, but anyway, you can generate signal this way or you can generate this way. So this is one polarity, this is other polarity. So you want to generate signal this way or this way, okay? Again, this is again a register. Every channel has 1 bit, as you see here. You can put 0 or 1, okay? So 0 for 1 polarity, 1 for the other polarity. Okay, I think normally if I want to change the signal, it should be this way normally. But anyway, if you want it to be this way, you can just control the polarity here. Again, you have a register for every channel. You have 2 values, either this polarity or this polarity, 0 or 1. Very easy. Okay. So what else you have here? Also, we have something we call alignment. You want the signal to be either, regardless of the polarity. You want a signal, you want to start from here to be something like that. You want to start this way. That's normally you will select align means this way. Or you want the signal to be this way. This is the signal I'm going to repeat. Normally, I'm going to do this way, right? Again, but we have option, you have another option to make it this way and repeat it, okay? And instead of making this way, just shift it. So for example, you have, let me explain it a better way. For example, here, yeah, usually you start this way, right? However, I can, for example, start this way, for example, and repeat. Anyway, I don't think I never use something like that, but you can control if you want to, regardless of the polarity. This is a polarity, okay? But regardless of the polarity, you want to start this way or you start this way. Anyway, so again, we have a register for alignment. We have one bit for one polarity, another value for other polarity. Okay? Sorry, for alignment. I think that's all what we have. Okay, now I'm going to explain one program. I'm going to show how it is just very easy, believe me. Okay, so for example, here, all what you have to do math calculations. So for example, I want to generate 100 kHz signal. Okay, for example, I'm going to use clock A. So if I use clock A, okay, so the frequency I'm going to get should equal 24 divided by base scale and period. So now this one should be 100 kHz. Is that right? That's what this is the signal I want to generate. So I have to select two values here. I have to select two values here so that I'm going to get this signal. Is that okay? So if I here, for example, that's why I have multiple solutions here. For example, if I put 1, so this one has to be 24. So 1 times 24, this is one solution. Another solution, I can put here 2 and put here whatever it is. Is that okay? So now, once you have these numbers, just write the number to the register. You are done. What I'm saying? That's what I'm going to show. Same thing here. Here I'm just giving you some more numbers. If you want to generate 500 kHz, okay, for example. So do the calculation. You have some numbers. So you have to write some number here and number here. Once you do that, it's done. And that's what I want to show here. Okay. So here, yeah. So the way the program works, guys, here, for example, this is to select clock A or scale A. So you need one instruction to do that, as I explained to you before. You need one instruction for the polarity. You need one instruction for the polarity. You need one instruction for the prescale. For example, here I decided to make the prescale 2. You remember when I put 1, it's going to be the prescale. There is a table, right? So if I put in the prescale 1, so the value will be 2. Okay, you will in the table anyway. Also, now I'm in the period. I'm going to put 120 in the period. In the duty cycle, I'm going to put 60. Is that okay? That's it. And also, once you finish, once you do this part, it's going to work. It's going to work. You are going to see the signal at any time. So what I did here, guys, I want to control this signal. So I want to use a switch here to turn the signal on or turn the signal off. Turn the signal on and off. So what I did here, guys, I'm going to check this bit. And then based on that, either I turn, enable, or disable the signal. Okay. So here, using this instruction, I told you I have a pin, one bit to enable or disable. So here I'm going to enable pulse width modulation. Here I'm going to disable, right? That's it. There is no, you don't need to do anything. Just once you do the initialization, everything is done. Unless you want to enable or disable, in this case, you have to use this one. Okay. Unless you want to change the frequency, you want to change the period, you have to modify this one. You want to change the duty cycle, you have to change this one. That's it. Okay, very interesting. Okay, So I think here also I give you some programs. One program here is very interesting program. I'm gonna here. I want to do what's called here. I want to dim the bulb. I want to dim it gradually. So I want to increase the brightness gradually. Then there are some systems to do that. I can decrease the light gradually, increase it gradually. You know how I can do that? I'm going to tell you how. Because, for example, if I apply this signal, the lighting is very little. If I increase the duty cycle little bit, I'm going to increase the lighting little bit. If I increase it little bit, I'm going to increase the lighting little bit. Right? That's how you can see the lighting increasing bit by bit, decreasing bit by bit. Okay. So how I can do that? How I can increase little bit? Very simple. The duty register, as you will see right now. Look what I did here. What I'm doing here, this is the duty register. Every 200 milliseconds, I increment by 1. So here, increments by 1, so I start with a certain value, and then every sometime I add one clock, so that I increase it. Okay, so as you increase the duty cycle, as more voltage, as more brightness. Okay, the last thing I want to teach here, guys, the last thing I want to teach, I almost finished. This is just very easy topic. I know it's important and just very easy. The last thing I want to teach, there is a feature here. There is a feature. What is the feature and why you need it? Okay, look here. I told you if you use, let me go back here. If you use, yeah, no, back more. Yeah, look here, guys. If I use clock A, so the range of frequencies I can generate in this range using clock A. Is that okay? If you use scaled A, so the range of frequencies I can use in this range. Is that okay? Range. What if I want to generate smaller frequency? So here your minimum is 2. What if I want less frequencies than that? What can I do? I'm going to tell you about the idea. The idea is that, look here, guys. The idea is, in order to calculate the minimum, here I have 24 megahertz. Here I have 24 megahertz. I'm going to divide it by pre-scale. I'm going to divide it by period, by the period, which is a byte. So this period, it's a byte. It can take a value from 1 to 256. By the way, someone can ask me, tell me, it's a byte. A byte should take a value from 0 to 255. Okay, so what they did, because I'm not going to divide by 0. What I'm getting, if you need 256, you have to put 0. So they are going to take the 0 as 256. Anyway, so you got what I'm saying, guys? So now, think about it. If I want to generate lower frequency than what I have here, what should I do? The idea is I have to increase this one. Instead of making it a byte, I'm going to make it a word so that I can divide by a bigger number. You got it? How can I make it a word? It's a byte. I'm going to tell you the idea. So again, the idea is that now I want to generate smaller or lower frequencies than what I have here. Okay. So I have to divide by a bigger number. So how I can get this bigger number if it is already a byte? So idea here, we call it concatenation. Concatenation. So concatenation means I have 80 channels, but I can concatenate 2 channels together. So, okay, so what's the benefit you will have when you concatenate? I'm going to tell you what is the benefit. The benefit, I'm going to get, I have register for period for one channel, which is a byte. I'm going to have another register, which is a byte for the other channel. So now I'm going to have a word. This word, I can divide by this word so that I can get. So now it's like I made, here. Yeah, here, like this one was a byte, like period, because this is for one channel. If I concatenate 2 channels together, I'm going to take the period from this channel, the period of this channel, and then I'm going to have a word. And I'm going to divide by this word so that I can get lower frequency. So this is a feature here. How I can do this feature, guys? Pretty simple. You have a register, this register. If you want to do concatenation, you just put 1 here. So here, 1 here means I'm going to concatenate channel 0 and channel 1. I'm going to concatenate channel 2 and 3. Or so you can concatenate only 2 channels. So it doesn't mean you have concatenate all of them or you don't concatenate at all. It doesn't mean that, okay? So I can use individual channel or I can concatenate. So the last thing I want to say, that's what I'm saying. This is 8-bit mode. 8-bit mode means no concatenation. If you concatenate, I'm going to call it 16-bit mode. And they call it 16-bit because the period is going to be 16-bit. Because I'm going to get the period from here, the period from here, I'm going to have 16-bit. Look how the beauty here. So in case of 8-bit, if I use clock A, this was my range. The range was from 24 until 732. However, if I use 16-bit mode, I can lower it more. Look here, I can lower it from 700 to only 2 hertz. This is for clock A. For sure, if you use scale T, it's going to be lower more than that. Okay, guys? Any questions? Okay. Anyway, this part is not in the final exam. At least you should understand what is pulse width modulation. Programming-wise, very trivial. You don't need to do anything programming. Just write to register. That's it, right? And then after you write to register, you have 1 bit to turn on and off. and then you have two register, one for duty cycle if you want to change the duty cycle, and have another one for the period. Okay, if you want to change the period. Is that okay? I think that's all what I have. Okay, so guys. So thanks. I wish you enjoyed this course and you learn it well in this course. Okay, good luck. See you. Bye.